All right, so let's check out answers to the back of number 2, your classifying chemical reactions. And please make sure on number 9 and 11 highlighted, both answers would be required on a test. You would need both answers for full credit. You would only get partial credit if you only pick one of them. All right, so check it out there. There's 1 through 11 on the board, 1 through 11. All right, we'll get some overlap here in the middle, but sliding down to get the rest. So here's through 20, and again, 9 and 11 needed both answers for full credit. Synthesis and combustion for 9 and 11. So questions on any problem on this side? Any of the classifications? You feel good? All right, so you can't forget to classify the ones that are 2. Remember, for 9 and 11, they're synthesis reactions because they both had one product, but they're also combustion reactions because they reacted with oxygen. Now, not every synthesis is also a combustion. If we look at number 15, that had one product and was synthesis, but notice there was no reacting with oxygen, so it was not also combustion. So make sure you're keeping an eye out for that, the synthesis that could also include combustion. Okay? All right, so with that, let's get a blank sheet of paper for number 6, predicting products notes. Predicting product notes. In chemistry honors, we are only going to be predicting products for single and double replacement reactions. You will not be predicting products for synthesis reactions. You would not be predicting products for decomposition reactions. That's a much more difficult task to accomplish. In fact, we don't even do much of it in AP chemistry anymore. There's just more things you have to look into and consider. But it's actually pretty straightforward with the single and double replacement reactions because they are involving ionic compounds with ions that have charges, and so we're just rearranging the charged ions to figure out what our new products are. Now, I'm not going to have you predict products for a combustion reaction, but there is some language in your curriculum that suggests that you guys should be able to do that. I'm not going to have you predict the products on any of your worksheets because we know from yesterday that combustion that you would be predicting products for would be this hydrocarbon combustion. And there's no trick that you have to figure out what the products are. It's just always carbon dioxide and water. So that's just something to keep in the back of your mind, not necessarily for my test, but at the end of the semester, I'll try to remind you again when we review. That is just kind of common knowledge that combustion reactions, hydrocarbon combustion reactions, they produce carbon dioxide and water. Right? Those are the products of hydrocarbon combustion. But for the single and double replacement reactions, those can make different things. So we have to do a little more work to figure out what those are. So for this number 1 here, if you have to classify a reaction where I don't give you the products, number 1, you can already eliminate some of your choices because I've told you your only options will be single or double replacement. You will never predict products for the other 3. Okay? So, in that case, if I have provided you an element reacting with a compound and then I don't give you any products, process of elimination, guys, what type of reaction does this have to be? An element plus a compound. This has to be a single replacement reaction because we learned yesterday single replacement reactions have an element and a compound on both sides. Well, if your only choices are single or double replacement, this meets the criteria at least for the first half of the single replacement. Whereas if I gave you a compound reacting with a different compound and expected you to predict products, what type of reaction does that have to be? Double replacement, because those are your only choices. FYI, I am going to start using abbreviations for the reaction types. I use SR for single replacement, DR for double replacement, and then I will just use S for synthesis, D for decomposition, and C for combustion. And I'm okay if you start using those abbreviations as well. All right, so what we're going to talk about here with predicting products, the first thing with number 2, we started doing yesterday. Usually with predicting products, it's about figuring out who's partnering up to make new compounds, right? Who's hooking up in the different reactions. And we already discussed yesterday how you know who to hook up. Because what had to be true of the 2 things that you were putting together?
Opposite charges.
They had to have opposite charges. So that's number 2, is just kind of deciding how are you going to rearrange things. And any new compounds that are made, they must pair a cation and an anion. And that's always the first step in the battle, if you will. It's just figuring out what you're going to put together. So with this in mind, I do strongly encourage you to review your polyatomic ions, because those will not get broken up in these reactions. If you have a nitrate as a reactant, you're going to have a nitrate as a product. If you have a carbonate as a reactant, you're going to have a carbonate as a product. And so sometimes when you guys are trying to figure out what to put together, sometimes you break apart your polyatomic ions, right, into carbon and oxygen, and you do some weird things. So if it's helpful if you can start to recognize the unit of the polyatomic ion. And that's going to be things that could be pairing up differently. Okay. All right, so once you know what's going together, the next step is writing the correct formula. In these types of questions, if you are making a new compound, every compound that you will make in these single and double replacement reactions will be ionic compounds. And so your job is, once you know what you're putting together, is to get the correct subscripts. How did we write formulas for ionic compounds that had the correct subscripts? Crisscross, right? So what you're going to have to do is, once you've decided, hey, I'm putting these 2 things together, you're going to have to look at their charges and crisscross them, right? You must do crisscross with the charges of the ions in the new compound. And that is the only way that you can determine the correct subscripts. You must do crisscross with the charges of the ions in the new compound to determine the correct subscripts. So what that means is that sometimes on the reactant side, you might have a subscript for an element. It will not be the same on the product side. And you might be like, but Mrs. Tate, they got to be the same. Guys, not the subscripts. The subscripts in chemical formulas is about satisfying octets, making neutral compounds. So maybe if I have an ion paired up with one thing on the reactant side, I needed one ratio to make it neutral. But if I put it with a different ion, I will probably need a different ratio. So you don't just blindly copy subscripts from one side to the other. Every subscript should come from crisscross. The only exception to this will be your polyatomic ions. The 3 with a nitrate stays with the nitrate, NO3. That 3 is part of the identity of nitrate. But if I just have the formula CaCl2, CaCl2 is calcium and chlorine, and the 1 and 2 are from crisscross. Because the 1 and the 2 don't make them calcium or chlorine. The 1 and the 2 is about a neutral compound. But nitrate's NO3. So guys, that's what you're going to be doing most of the time. For any compounds, you're doing crisscross. Mrs. Tate, what if it's a molecular compound? Guys, you're not going to see that if you're predicting products. If you would have a molecular compound, I would have written out the name for the molecular compound. And then you would see prefixes, right? Mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. And I'm going to be upfront, you will not see a lot of those. Most of what we're going to be doing is ionic stuff. All right, so on rare occasions, for those single replacement reactions only, you're going to be making a new element. And later, you're just going to be turning words into equations, and you're going to have compounds and elements. When you guys are writing down the formula for an element, you do not write the charge. Elements made in chemical reactions are not ions. They are neutral atoms of that particular element. So sometimes I'll talk about what charge it would have if it formed an ion, but in the reaction itself, if it's an element, it is neutral. It does not have a charge. However, you will have to ask yourself one question. Ask yourself if the element is a diatomic molecule. That is the only thing that you'll have to consider for your elements, is if it is a diatomic molecule. Because what will I have to add to the formula if it's a diatomic molecule? What do you add to the chemical formula of an element if it exists as a diatomic molecule? A 2. What kind of 2? A subscript 2, right? Because that's how they exist in nature. When you're writing the formulas for the elements, you just have to write how they exist naturally, right? On the planet. And diatomic molecules naturally exist in pairs. So if your answer is yes, you're going to add a subscript 2. If your answer is no, you're done. You simply write the symbol for the element, no charge next to it, and then you're done. Nothing else to write. So, just to remind us of our diatomic molecules, Brinkelhoff is the name, or you can look on the periodic table. So Brinkelhoff includes bromine, iodine, nitrogen, chlorine, there's your Brinkel, and then Hoff, H-O-F. So anytime any of those elements are part of your equations, whether it's a reactant or a product, if it is just hydrogen by itself, I'm going to have to put H2. Now, just one thing to point out. You never ask yourself this question if it's a compound. Compounds are about crisscross. You only have to ask yourself if it's diatomic when it is an element by itself, not in a compound. Compounds, you can do whatever with the subscripts, right? There's no rule except octets. Okay, so that's how you write formulas. So once you know what goes together if you're predicting products, or later today, we're actually going to be writing equation or formulas for reactants and products from names. This is how we write the formulas for compounds. This is how we write the formulas for elements. Only after we have all of the correct formulas, then we can look at balancing. You should never be thinking about balancing until you're done with your formulas. So that's number 5. Once all the formulas are written correctly. And how do we write the formulas correctly? Go back and look at number 3 and 4. 3 tells you how to write them correctly for compounds, 4 for elements. Then and only then can you start balancing. Once all the formulas are written correctly, then you can balance the equation by adding coefficients. So besides kind of messing stuff up with breaking up polyatomic ions, other things that are common is you guys write them in the wrong order. Remember, the cation is always first, the anion is always second. And then the last thing is sometimes you guys are trying to balance while you're writing the formulas instead of just treating the formulas individually, trying to write those correctly and then doing the balancing later. So let me show you an example here where we're going to predict products, write formulas, do all of that fun stuff. So here we go, example 1. I'm going to have some NiCl2, and we're going to react it with some KNO3. It's your job to predict the products, balance it, classify it. Okay. Now, on this worksheet that you're getting today, it's not going to matter what order you put your products in, but eventually when we take our test, I want to make sure that we have all of our coefficients in the same order. So what I'm going to do on both your test review and your test is on the product side, you're going to see blanks, and underneath them, they're going to be labeled. For this question, underneath the first blanks, it would say nickel compound, which means whatever compound nickel's forming, I want it to go in that spot. And then I'll have another blank, the first one for the coefficient, the second one for the formula, and it's just going to say other compound, right? Because I don't want to give you a hint what's in it, so it's just going to be the one that doesn't have nickel. And so that way, it's not because it has to go in that order, but then that means on our clicker, we'll have our coefficients in the same order. But on the worksheet today, it doesn't matter. As long as the products are there, it won't matter which order they go in. All right, so here we go. This is my question. My job is to predict the products with the correct formulas, balance it, classify it. I sometimes start out with classifying because I already know what type of reaction this is if I'm making you predict products. It's got to be a double replacement reaction. So I usually have a spot in the bottom right to label that. This is a double replacement reaction. All right, so in a double replacement reaction, remember the trick that I told you guys about putting together outsides and putting together insides, right? That will always ensure that you have a cation and an anion together. So your job is just figuring out what are the different pieces. In the case of the NiCl2, that's pretty straightforward. You got nickel and you have chlorine. But over here, even though there's 3 elements, remember there's 2 ions. What are my 2 ions? Potassium and nitrate. So when I say put together the outsides, the nitrate is the outside part. And so that's going to be one of my products, is putting together the nickel and the nitrate. And then my other product is going to be putting together this chlorine and the potassium. Right? Okay, So, knowing that, we know that we're putting together the nickel and the nitrate. The formula for nickel is Ni. Now, I know there was no subscript there, but it wouldn't matter if there was. No subscript is needed to make that nickel. If there was a subscript with that nickel, it came from doing crisscross with nickel and the other element. But nitrate. Guys, 3 is part of nitrate. The 3 is not there from crisscross. The 3 is what makes this nitrate. So I do need to write the 3 over there for the nitrate. But to make sure I have the correct subscripts, I have to do crisscross with their charges. This is going to create an issue for us because we know the charge of the nitrate. We do need to go back and review and memorize those. But we do not know the charge for nickel. Nickel is here in the D block. And you guys remember the only ones in the D block that we know the charges of is we know zinc is +2. We know cadmium is +2. That's a 2. And then we know silver is +1. Those are the only 3 elements in the D block that we know their charges. So I've intentionally done this one because it is more difficult. They're not always this difficult. I need to figure out the charge of the nickel. And the way I'm going to do that is I'm going to focus on this formula right here. Because if I can figure out the charge of the nickel in this formula, the charges don't change. The charge of the nickel on the reactant side will be the same charge as the nickel on the product side. So if you're asking yourself, how do I figure out the charge of the nickel? Well, do you guys remember when we would figure out Roman numerals? The Roman numeral was the charge. So if I can figure out the Roman numeral is the charge. I have figured out the charge. So just for space, I'm going to rewrite this down here. Remember what I would say is that I would say I know that the charge of the chlorine is -2. Let's maybe go back and review that real quick. Do you guys remember that group 1 is +1, group 2 is +2, group 13 is +3, group 14 +4, and then what happened when we got to 15?
0.
Nope, -3. -3, -2, -1. And so that's why I just said the chlorine was -1. Okay, so the chlorine's -1. But then remember, we don't know what the nickel is. It's X. Is this coming back to us a little bit? All right, and so then I did some multiplying. I would multiply those charges by the subscripts. Here it was X times an imaginary 1, because there's only 1 nickel. All of the charges would still be X. And then I multiplied the -1 by the 2. Each chlorine is -1, but there's 2 of them for a total of -2. And then adding this together, I know compounds are neutral. So, what is the charge of the nickel? It's +2. Right? Now, Mrs. Tate, could I have kind of looked at the subscript of the chlorine, almost doing like a reverse crisscross thing? It does work in this case. You just need to be careful because if I gave you, not MgO, if I gave you MnO, you don't have to write this down. I'm going to erase it. If I gave you MnO, you might be like, oh, there's 1 of each. That must mean it's +1, -1. Guys, oxygen's not -1. What's oxygen?
-2.
Oxygen's -2, which means this Mn was +2 and I had simplified it. That's why there were no subscripts. So you just need to be careful if there is simplification involved with your crisscross. All right, but what we just figured out here, we did figure out that X is a +2. That is the charge of our nickel. And if that was the charge of the nickel over here, guess what? That's the charge of my nickel over here. And then nitrate. Do we remember the charge of nitrate? Nitrate's -1. So doing crisscross, doesn't the 2 from the nickel have to get crossed to the nitrate? Which means I'm going to have to take that nitrate, I'm going to have to stick it in parentheses and put a subscript 2 on the outside. But Mrs. Tate, it's not that way on the left side. Guys, that's fine. You're not balancing right now. You're just writing neutral formulas. And if I have a +2 nickel, I need 2 -1 nitrates to make it neutral. Okay, so that's our first compound. There's our nickel 2 nitrate. For our second compound, we're putting together the insides. Guys, the cation has to go first. So if potassium was the cation here, and it went first, the potassium has to be the cation and go first on this side. And then this Cl. do I write this 2 over on the product side? Do I need that 2 to make it chlorine? No. Where did that 2 come from? It came from crisscross with nickel, right? I needed 2 chlorines to make a neutral compound with nickel, but it's not with nickel anymore. So I don't know how many I'm going to need. I might need 2, I might need 3, I might need 1. I got to figure it out with crisscross. So that's an example of, see how I wrote the 3 because that's part of nitrate, but the 2 is not part of chlorine. The 2 was just for crisscross. Okay, so the K and the Cl go together, and then I need to crisscross their charges. So thankfully this one's a lot easier because here's potassium, its charge, +1. Here's chlorine, its charge, -1. Right? So if my potassium is +1 and my chlorine is -1, do I need to put any subscripts? Nope. I'm done. I'm done with the formulas. So let's pause there. Questions on what I just did to come up with the formulas for my products? How did I know what to put together? Where did I get the charges from? Go.
How come you don't put the +2 on the nickel as a subscript? Like, yeah, a subscript.
It crossed over here.
Oh, that's
Yeah, you crisscross.
oh, okay.
Yeah, it's a -1 for the nitrate. The -1 from the nitrate doesn't get written when it crosses. All right, other questions? Okay. So now that we have the correct formulas, now we can balance. All right, now we can go back and balance. So for some of these, you guys should maybe be getting a little better at balancing by inspection. So when I balance by inspection, remember I just kind of focus on one element at a time and do what I need to do to fix it. In this case, if I look at those nickels, they're balanced right now. Can we agree there's one of each? Okay, so I don't need to do anything to fix that. So then I'm going to focus on these chlorines. Are the chlorines balanced? No, I've got a subscript 2 here, so I've got 2 chlorines on this side, but I only have 1 chlorine on that side. So to balance this, I'm going to put a coefficient 2 here. And then that's it. I fixed my chlorines. I'm just going to keep moving on because that hasn't changed anything that I already looked at. So now I'm going to look at my potassiums. Are my potassiums balanced? The answer is because I put a coefficient here, no, they're not balanced anymore. On the right side, I've got 2 potassiums. So on the left side, I need to put a 2 to get 2 potassiums. Okay, and again, that's going to change the nitrate, but I haven't even looked at the nitrates yet. So now looking at the nitrates, are the nitrates balanced? The answer is yes. I've got a coefficient on the left side, but I've got a subscript on the right side that make 2 of each. When you're balancing by inspection, I always encourage maybe just to go back through one more time and check because sometimes adding a coefficient might mess up something that you previously thought was balanced. The other option is as soon as you notice that you messed up something that you previously had looked at, go back and fix it right away. Just make sure that you kind of do that final check. And so that's balanced. 1, 2, 1, 2 would be the answer in the clicker. So that is predicting products, writing formulas, and then balancing, classifying. Question?
On our test, when we're balancing, do we type into the clicker the numbers or is it A, B, C, D?
You're going to type in numbers into the clicker on your test. Okay. All right, so with that, let's take a look at your worksheet. You may notice when this is due. This worksheet is not due until Tuesday. The reason why is that I will not be here Monday morning. I have an appointment in the morning. I'm going to be here in the afternoon, but I won't be here in the morning. So the instructions for the sub that I'm telling you guys is work on this worksheet. If you want to get some of it done over the weekend, you can, but you don't have to. But this whole worksheet, front and back, is due on Tuesday. Right? Now, since some of you I know are just going to get this and get it done, I'm also going to have your test review for the sub to give you on Monday. But the test review will not be due until Wednesday. So the idea is you have class time Monday to work on this paper. You'll have class time Tuesday to work on the test review, but I'm just giving you everything a day earlier. Okay, so kind of use your schedule, use your comfort level. Some of you are taking longer, and you need to get more comfortable and start working a little quicker with your balancing. Okay? On the front, you're actually not predicting products on the front. On the front, all you are doing is you are turning the words into formulas. Once you turn the words into formulas, then you're going to balance, and then please add to your directions. I would also like you to classify each of these as synthesis, decomposition, single replacement, double replacement, or combustion. Since you're not predicting products, you can do that. I do need to put a little note there, though, and that is look at number 7. Number 7, you will not be able to classify. Classify. It will not fit into one of your 5 categories, so don't try. That one you don't have to classify, but the rest will. Okay. So I'm going to do example here in just a second, but when you're doing these, you still follow the same idea for when we were predicting products. If you have an element, check to see if it's diatomic. So do you see here where it says zinc? I'm just going to write the formula. I don't write a charge. I just write the formula for zinc, and then I just will need to ask myself, is it diatomic? For your compounds, most of them are going to be ionic. And when I say most, I think all but one. They're all ionic compounds with metals. And so how do we write formulas for ionic compounds? Crisscross. So you're going to be doing crisscross. Where it says yield, you're going to be putting your arrow, right? You're just turning the words into the formulas. I will help you out. Go back and look at that number 7. Do you guys see sulfur dioxide? You're not crisscrossing that. That's prefixes. You're just turning the prefixes into the subscripts. So I'm just going to give you a hint on that one. Also water, like you know the formula for water. So you don't have to worry about doing crisscross on those. I've given you chemical formulas for some of the acids if you look at 5, 6, and 7, so you can just write those formulas down. Okay. I will tell you though on the back there's some acids, and so you should recognize that for each of those there's a hydrogen ion and then there's an anion. So even though that's called hydrochloric acid, that's a hydrogen ion and a chloride ion. And even though that's called phosphoric acid, that's 3 hydrogen ions and a phosphate ion. And sulfuric acid is 2 hydrogen ions and a sulfate ion. So in terms of crisscross and trying to figure out who you're going to pair things up with, it is just 2 ions, even though it's not named that way. I saw a hand over there. Are we good? Okay. All right. Ooh, I do see a monoxide right here too. Okay. All right, so with that, I'm going to go do number 1 with you real quick, just so you can see an example. All right, so for number 1, it starts off with zinc. Guys, when you have an element, you simply write the symbol for the element, and then you ask if it's diatomic. Is zinc diatomic? Nope. Then guess what? Plus sign, moving on. If it was diatomic, I'd put a subscript 2. Remember, elements don't get charges. All right, so then, lead 2 nitrate. That's got a metal. This is an ionic compound. It doesn't have any prefixes in it. We have to do crisscross. That means I need the charges of both ions. What is the charge of lead 2? Guys, remember the Roman numeral is the charge. So the charge of lead 2, I'm just going to write it up here, is 2. And then what's the charge of nitrate? -1. So when I crisscross those, I'm going to end up with Pb for my lead. I don't write the 1 that I crisscrossed from the nitrate. And then I'm going to write my formula for nitrate, NO3, and I'm going to stick that in parentheses because afterwards I have to write the 2 that I crisscrossed from the lead. So that is lead 2 nitrate, turning the words into formulas. Yield, I put an arrow. Then I'm yielding zinc nitrate. That's a metal. This is an ionic compound. No prefixes here. I got to crisscross. Unfortunately, zinc is one of those transition metals that we have to memorize their charge. And the charge of zinc is +2. So this zinc is +2. Oops, over here. And then the nitrate hasn't changed. Still -1. Oh, so that's going to be very similar to the last one, just with different elements here. Now we're going to have Zn zinc parentheses NO3 close parentheses 2. All right, and then so we end with lead. That's an element. So put the symbol for the element. Ask yourself, is it diatomic? Nope, you're done. So now that I've written this, I can balance it. How many zincs do we have on both sides? 1. Or I should have said, are the zincs balanced? Yes, there's 1 each. Are the leads balanced? Yeah, there's 1 each. Are the nitrates balanced? Oh, guess what? This is already balanced. The coefficients would be 1, 1, 1, 1. So lastly, don't forget, classify it. How would I classify this reaction? Ooh, this is single replacement. You can just write that in the bottom corner. Done. So that's what you'll be following through. For, again, a lot of them, it's going to be ionic compounds for the compounds, with a few exception of prefixes closer to the bottom.
For number 4, do we have to do a symbol rewrite for when needed?
Okay, so good question. I was actually going to bring this up. I forgot. Some of the questions will say things like oxygen gas, hydrogen gas. I'm not expecting you to write phases, so you don't need to put the phase in. And then for the when heated, again, I'm focusing just on the formulas, the balancing, the classifying. If you want to practice that, I'm not going to penalize you if you don't do it. But you could be. Yeah, it'd be the triangle. So, but it's optional, really. At minimum, you need formulas, coefficients, classify. All right, so that's the front, just practicing writing formulas, really, and then balancing and classifying. Let's take a look at the back. On the back, you're doing a lot of different things. You are going to, in words, predict the products. Then you're going to turn those words into formulas, write a balanced equation, and you're going to classify it. So, since I already had done a double replacement example in our notes, I'm going to do number 2 with you right now. So that way on Monday, hopefully, you have some stuff to look at to help you. So for number 2, we are reacting aluminum and iron to oxide. So first off, I can already tell what type of reaction this is. It is a, what type? Single replacement. I know that because I'm only asking you to predict single or double replacement, and this had an element in it. Okay. So if I'm doing a single replacement reaction, that's the home wrecker, my first step is figuring out who is the aluminum going to partner up with. To answer that question, I have to know, when aluminum forms an ion, will it have a positive or negative charge? And aluminum right here is going to have a positive charge, specifically +3, but just knowing that, if aluminum is going to be positive, who is it pairing up with, the iron or the oxide? Oxide. So watch what I'm going to do for my names. It's really nice with my names because I'm just going to put the 2 names together. Aluminum oxide, and the one that got kicked out, iron. Notice how I don't write a Roman numeral, because now it's a neutral element. Roman numerals only go in compounds. You'll never see a Roman numeral next to just an element. Okay, so does everybody understand why I put the aluminum and the oxygen together and not the aluminum and the iron? Aluminum and iron would both be positively charged. Not cool, bro. Have to put oppositely charged ones together. So guys, now this is kind of like the front. I'm just turning everything into formulas. So aluminum's an atom, or excuse me, an element, right? So start off by writing the element symbol. And then, what else do we do for elements? Check if it's diatomic. Is it diatomic? No. Hey, let's just pretend. Let's pretend it was. If it was diatomic, what would I do? I would put a subscript 2 and then keep going, but it's not, so don't put the subscript 2. All right, so then, now I need to write the formula for iron 2 oxide. These will all be ionic compounds on the back, so we will be doing crisscross for all of them. That means I need charges. What's the charge of iron? Oh, it's iron 2, you tell me? That means its charge is plus 2. What's the charge of oxide? Ooh, oxide, that's oxygen.
Oh.
Negative 2. Right?
The show our work and like write out +2, -2.
No, the red part is just the work. Right? The answers are what I'm putting in blue and green.
Like, do we have to show our work?
No. All right, so there's -2. And so when I'm crisscrossing, +2, -2. Oh, those are going to cancel out, right? They're going to simplify to ones. So we're just going to be left with F, E, and O. All right, so then we have our arrow, and then now we have to write the formula for aluminum oxide. Now you got to crisscross for that aluminum oxide. So we'd already just said what was the charge of the aluminum going to be? Aluminum is +3. And then oxide, -2. Those don't simplify. So I'm going to have 2 subscripts here when I cross it. I'm going to have AL, and what will the subscript be on the AL? AL2, just a 2. Remember, you get rid of the plus and minus signs, and then O3. All right, so done with that compound, and then lastly, we have an element. Write the symbol for the element, and then ask, is it diatomic? No, it is not, so we are done with our formulas. Now we get to balance. If you're feeling good with balancing by inspection, you can still do that, but FYI, I also have had students who make their lists out here in the margin to do their balancing, if that's something that you would like to do, or use a separate sheet if you want. I promise you'll see your test review is going to look very similar to your test, and there's plenty of room to make a list on your test review and your test. Okay. All right, but let's balance by inspection. I'm going to start first with these aluminums. Are they balanced? Nope. I got to fix that, right? So won't that fix my aluminums there by putting the coefficient 2 in the front? Okay, so aluminums are good. Then let's go to the irons. Are the irons balanced?
Yeah.
Yep, those are good. All right, so then let's go to the oxygens. Are the oxygens balanced? Nope, got to fix that. Won't that fix my oxygens?
Yeah.
Okay, but then that also did what?
Messed up your iron.
Messed up the iron. So let's take a look at the irons again. They're not balanced anymore, but it's an easy fix. Just putting a 3 in there. And then just double check, still got 2 aluminum, still got 3 irons, still got 3 oxygens, we're good to go. And so we are done. And again, in terms of what I'm looking for, these red numbers, the charges, were just there to help me do crisscross. They are not required, nor am I requiring you to make a list, but I strongly encourage it on test day. Okay, so review. This worksheet front and back, not due until Tuesday. You have all class Monday to work on it. You can just sit down and start working when you get here. On Monday, the sub is also supposed to put on the front table your test review. This is what your test review will look like. It will look identical to your test. Notice you're going to do some predicting products at the beginning. You're going to be classifying over here. Okay? Some you're just going to balance. And then here are some word equations. Right? This test review that you get on Monday will not be due until Wednesday. So keep on Canvas. Canvas does have accurate deadlines for all of the papers. And I will be here Monday afternoon if you would like to stop by with any specific questions that you might have. Okay? I'm only gone in the morning.